back to my video. My name is Asima Sulys Simanjuntak. My ID number 41931111045. I'm a college student from Mathematics Education Study Program 2019 at State University of Medan. Now, I want to explain about the development of modern mathematics from transitional century to 21st century. This is the last chapter. First, I want to explain about the scientific revolution period. There are first, 17th century. The 17th century witnessed an unprecedented increase in mathematical and scientific ideas throughout Europe. Galileo Galilei was able to observe Jupiter's moons with his homemade telescope based on toys imported from Holland. Tycho Brahe managed to collect a large amount of mathematical data describing the position of the planet in space. Johannes Kepler studied the motion of the planet seriously and put forward Kepler's laws. He also made a mathematical formula of the laws of planetary motion. René Descartes developed analytic geometry by placing the orbits of the planet onto a graph of Cartesian coordinates. Isaac Newton is perhaps best known for his contribution to physics. However, his service in mathematics should not be underestimated. His most famous work is the Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy, which was first published on 5 July 1687. Another discoverer of calculus was Gottfried Wilhelm von Leibniz. He is considered one of the most important mathematicians in history. Separately from Newton, Leibniz developed differential and integral calculus. In his calculus, Leibniz introduced a notation that is still widely used today, like the for different and for integral. Leibniz also contributed to algebra and topology. And number 2, 18th century. The most influential mathematician of the 18th century was arguably Leonhard Euler. One of his contributions was the discovery of the study of group theory, with the 7 bridges of Königsberg for standardizing many modern mathematical terms and notations. For example, it represents the square root of -1 with the symbol e. He also popularized the symbol p to express the ratio between the circumference of a circle and its diameter. He made many contributions in topology, graph theory, calculus combinatorics, and complex analysis. Another important mathematician of the 18th century was Joseph Louis Lagrange, who did pioneering work in number theory, algebra, differential calculus, and the calculus of variations. There was also Laplace, who had done important work on the foundation of celestial mechanics and statistics. Okay, the modern era. First, 19th century. During the 19th century, mathematics became increasingly abstract. Carl Friedrich Gauss, known as the Prince of Mathematics, made revolutionary work on complex variable function and the convergence of series. He was also the first to give satisfactory proof of the fundamental theorem of algebra and the quadratic reciprocity law. The 19th century saw the beginnings of much abstract algebra. Hermann Grassmann in Germany provided the first version of vector space. William Roman, elemented in Ireland, developed the non-communicative algebra. The British mathematician George Boole devised an algebra that soon evolved into Boolean algebra, which contains only the number 0 and 1. Boolean algebra became the starting point of mathematical logic and had an important role in computer science. Augustin Louis Cauchy, Bernhard Riemann, and Carl Weiss Thus, reformulated calculus in a more rigid way. In this century too, for the first time the boundaries of mathematics were explored. Niels Henrik Abel, or Norway, the Faristeglois of France, proved that there is no general algebraic method for solving polynomial equations with more than 4 degrees, or Abel-Ruffini theorem. On the other hand, the three-dimensional limitation in geometry was accepted in the 19th century by considering the parameter space and hypercomplex number. Abel and Galois' investigation into the solution of various polynomial equations laid the foundation for the development of group theory, as well as fields related to abstract algebra. In the late 19th century, Georges Cantor built the first foundation of set theory, which allows us to understand precisely the idea of infinity and has become of common language in almost all branches of mathematics. Cantor set theory and mathematical logic developed by Peano, L.E.Z. Brouwer, David Hilbert, Bertrand Russell, and A.N. Whitehead are considered the basic foundation of mathematics. And next, number 2, 20th century. The 20th century saw how mathematics become a mainstream profession. Every year, thousands of doctorate or PhD degrees in mathematics area are awarded, and there are many jobs available in education and industry. In 1900, David Hilbert, in a speech to the International Congress of Mathematicians, presented a list of 23 unsolved problems in mathematics. This problem, which covers many areas of mathematics, became the main focus of much of the mathematics century, the 20th century. Wolfgang Haken and Kenneth Appel used computer to prove the four-color theorem. Andrew Wiles proved Fermat's last theorem or Fermat's last theorem. And next, Thomas Callister Hales proved the Kepler conjecture. Differential geometry emerged when Einstein used it in general relativity. Entirely new fields of mathematics such as mathematical logic, topology, and game theory have changed the type of questions that can be answered by mathematical methods. All types of structure are abstracted by axioms and given names like metric space, topological space, and etc. The concept of abstract structure leads to category theory, grothe and Serre constructed algebraic geometry using shift theory. Great progress was made in the qualitative study of dynamical systems started by Poincare. Other new fields include Lawrence Coward's distribution theory, fixed point theory, singularity theory, and Rene Thom's Kataspron theory, model theory, and Mandelbrot fractals. The continuous development and improvement of computers allow industry to deal with larger and larger amounts of data to facilitate mass production, distribution, and communication. With this development, new fields of mathematics have also developed, including Alan Turing's computability theory, complexity theory, data analysis, and optimization. In the previous century, most mathematics focused on calculus and continuous function, but the development of computing and communication networks made the concept of discrete and combinatoric expansions even more important, including graph theory. One of the most interesting mathematicians in 20th century was Srivastava Iyengar, Ramanujan, and India self-taught, who had wished and proved more than 3,000 theorems, including properties of very high composite numbers, partition function, and their asymptote, as well as a mock data function. He also made major investigation into gamma function, modular forms, divergent series, hypergeometric series, and prime number theory. Then, in the mid-20th century in the United States, there was a mathematics teaching project led by Beberman in 1952, namely UISM, the University of Illinois Community on School Mathematics, which emphasized understanding and discovery. Because this project is the forerunner of modern mathematics, Baberman, as the leader of the project, is called the father of modern mathematics. One of them created a modern mathematics movement, which is a continuation of the UECSM project, namely the SMSG or School Mathematics Study Group project led by Dr. A, and the result of which were able to make a big difference not only in America but also for the teaching of mathematics around the world. Number 3, 21st century. In 2000, the Clay Mathematical Institute announced 7 Millennium Prize problem, and in 2003, the censure was solved by Grigory Perelman, who refused to accept the award because of his critical attitude towards the establishment of mathematics. Many mathematics journals now have an online version, such as the print version, and many journals are only published online. There are many observable trends in mathematics, the most notable of which are that the subject is getting bigger, computers are getting more important and powerful. The application of mathematics to bioinformations is growing rapidly, and the volume of data generated by science and industry facilitated by computers is exponentially growing. Okay, I think that's all from me that I can explain about the topic development of modern mathematics from transitional century to 21st century. There is my last chapter of this video. If I have a mistake, I apologize. And if there are critique or suggestion, you can write them in the comment column. Hopefully, this explanation video is useful for you. Thank you for watching and see you in the next video.